Hello, my name is Deniz Görg. I'm an application engineer for optocouplers at Vishay Semiconductor. Now I'm gonna introduce you our demo board, which is a comparison of electromechanical relays and our solid-state relays. First, let me start with the basic structure of two components. They are both used for isolation goals, and the first picture on the left belongs to the electromechanical relay. On the input, we see a core mechanism which, when powered on, creates a magnetic force. This magnetic force pulls the arm here, and the other side of the arm pushes the load circuitry, load contacts together and completes the load circuitry, which is how the switch-on process is activated. On the other hand, our solid-state relays, on the input, they consist of a light-emitting diode. When powered on, this LED emits light, and via this light, the photodiode array on the output becomes activated. This photodiode array, which is also a photovoltaic cell, powers the gate contacts of the MOSFETs on the output. Now show you a schematic of our demo board. The point of this demo board is to compare the output signal of each component. It's powered by a power adapter which gets the voltage from, which is connected to the line voltage. And it has an internal timer IC part, NE555. This IC part generates the input pulse for both components at the same time with the same frequency. Once they're powered on, we will be able to also see the output signals on our oscilloscope. On the board, we have the test points here, which we connect to the test probes of the oscilloscope so that we can compare the output signals. We have the power plug-in here, the electromechanical relay, the SSR, and the timer part. So I have already plugged in the connected the test probes of the oscilloscope with the test points on the board. Now all I have to do is to connect the power adapter with the board. Now you already can hear the switching behavior of the electromechanical relay. The light that you see here from the LED, this is an external component for the electromechanical relay. During the switch-off process, the relay needs to be discharged, so it needs an additional and external component, such as a flyback diode, and in order to make this visual, we installed an LED. On the oscilloscope screen, we can see the three different curves. The pink one belongs to our input signal. The blue one is the output signal from the solid-state relay, and the yellow one is the output signal from the electromechanical relay. What we can immediately see is that as soon as the input signal arrives, our solid state is capable of turning on very fast. In case of the electromechanical relay, there is a certain delay time which we can easily see. Another characteristic of mechanical relays that we can observe here is the bouncing effect. Since there is a real mechanical movement during the switching process, which causes vibrations, it doesn't create a smooth turn-on behavior, which is why we are able to see the vibrations also with the curve of the mechanical relay. So let me sum up the advantages of our solid-state relays. As you can see on the board, solid-state relays take up less space compared to electromechanical relays. As you can hear during the switch-off process, solid-state relays are quiet compared to mechanical relays. And as we observed from the oscilloscope, there is no bouncing effect during the switching process. And since there is no mechanical movement, this gives us a long-term stability and longer lifetime with our solid-state relays. Thank you for watching. If you need to have more information about our products, you can visit our website vishay.com/optocouplers.